In this lesson, we're going to talk about how to find higher order derivatives. So the big idea here is really the question, what happens if you take a derivative more than once? And so if I have a function like this, f of x equals x squared minus 2x plus 5, and I took the derivative, so f prime of x, in this case, using power rule, I'm going to get 2x minus 2. And then remember the derivative of 5 is just 0. So if I'm given my derivative, f prime of x equals 2x minus 2, I could find the derivative of the derivative, which we call a second derivative. And I denote it as f double prime of x. So the second derivative in this case, I'm just going to take the derivative of the first derivative. So I end up with 2. The derivative of 2x is 2. The derivative of negative 2 is 0. So this is what happens whenever I try to find a derivative more than one time. I find the second derivative. I could even keep going, and I could find the third derivative, and I would end up with 0. The fourth derivative would also be 0, fifth, sixth, and so on. So there's some notation that goes along with finding higher order derivatives. And like you saw in the last example, we denote the first derivative with a single apostrophe, or we call it a prime. So this is f prime of x. And using your power rule, you get 5 halves x to the 3 halves. The second derivative we denote with 2 marks, so we call it f double prime of x. So this is going to be 5 halves times 3 halves times x to the 1/2 power. So still using power rule. So I can simplify here to get 15 over 4 x to the 1/2. And you could keep going. You could find the third derivative if you wanted to, the fourth, and et cetera, et cetera, et cetera. The cool thing here is that higher order derivatives that are polynomials are going to continually break down until you get 0. But whenever you have functions maybe with fractional exponents or negative exponents, your value isn't actually going to ever become just 0. So you could keep taking derivative after derivative after derivative. So this is kind of our standard function notation and how we denote derivatives using functions. You can also use Leibniz type of notation whenever you want to denote derivatives as well. So the derivative of y we could call dy dx. So dy dx is equal to 2x minus 3. So if I wanted to find the second derivative then, what I could do is I could say d squared y over dx squared. And so what this says is the second derivative of y with respect to x, just like this is the first derivative of y with respect to x. And so the way we denote it is d squared y over dx squared. But just keep in mind that these aren't actually powers. So the derivative of 2x minus 3 we know is just 2. So we can denote the second derivative in different ways using function notation or using Leibniz notation.